Okay, and the columns are basically buying basically that whether the people are buying this thing or not, this car or not. Okay, that either they are buying it in lesser number or more in number, or its sales is moderate. Okay, second column is what we call maintenance column, that whether this car is having a high maintenance, low maintenance, or very high maintenance. Because if you are having a luxurious car, then obviously it will be having high maintenance. So these all things are signified by this. And this feature is like the doors, the number of doors. For example, you buy a Ferrari. Okay, so what will happen? It will have you having only 2 doors. But if you buy a Bolero, it will be having 5 or 6 doors. Okay, so it depends on car to car. So also the capacity of the car is shown by this field, capacity, the number of persons it can have. Luxurious boot, so it's like another feature, but I'm not sure of what exactly it, but it's I have to see. And another is, last one is safety. Okay, safety is like a very low safety, it is having airbags or not, its performance on airbags and accidents is good or not, it's stable or not, balance and all. Okay, and last thing is the class, which is a target variable. Okay, so it's a there are few classes, that's inaccurate, good, very good, and all. We'll be seeing it also, that which all things is suitable for this, whether we should buy this car or not. So this is the thing about our dataset. Now next we'll be looking and seeing some info about our columns. So we ran the column and we found that okay, that is having 1728 entries as expected, and not any null object. This means we are lucky that we are having any NaN or not null values, so we don't have to work on filtering much. This is already filtered data, so I have taken that data as like that. Okay, now let's see what are the distribution of our variables in data. So this is the features, like the buying feature is having 4 classes: high, very high, low. Okay, and their counts basically. Okay, and the target variable, it's let's see here, this is a very important thing. It's having 4 classes: unaccurate, accurate, good, and very good. So these are the 4 classes we are going to classify our output. Okay, so we'll be looking, and there are some other features we have already: person, number of 2, like let's say number of doors. There are 3 classes: 4, more, and 2. This is a general pattern, that either a car will have 2 doors, 4 doors, or even 5 or 6, depending upon the size of the car or the provider. Okay, so this is about the data set and the classes they are having. So it seems like it is pretty much a categorical data. Everything is almost in type of objects. Okay, so summary we can see here, there are 7 variables in the data set. All of them are categorical. Okay, it's obvious, and these are our target or features or inputs, and this is class is our target variable. Okay, so let's run and see the number of classes. So these all are classes, and their frequency distribution. So inaccurate, accurate, good, and very good. Okay, now let's see if there are any missing values in our data set. So luckily there are no missing values, as I've already told you. This is a very clean and filtered data, so we don't have to bother about filtering and cleaning it. So we are lucky upon that. Okay, next what we are doing is that we have to create our feature vector and target variable. So what we'll be doing, so let's say this is our data set. Okay, this is our data set, and up to here these are our features, or basically inputs, and from here this is our output, or basically y. So for creating the input vector, what we'll be doing, we'll be taking the whole data set and removing the class out of it. We'll be removing class out of it. Okay, and For the output variable, we'll be taking the whole, we'll be only taking this column. So this is how we are doing with this command. We'll be doing this. Okay, so just run this command and get ahead. So we run this command and divided our data into dependent and independent feature. Next we'll be doing train and test split. You already know, if you have learned come to this much, that random forest, you already know what train and test splits are. Basically we are dividing our data into train and test. For train we will be having X input and Y output. For test we will be having X input and Y output. Okay, so we'll be just importing train test split from the sklearn. Sklearn is a very popular library. Okay, you obviously know, and it's having predefined and pre-implemented algorithms already written for us. So we are just defining the test size to be 33. 0.33 means 33% of the data will be used as test and the remaining will be used as training. So, and we are having a random state variable. It's a random variable. You can initialize it with anything, 10, 20, 42, just random. Okay, and run, and we'll run test train split. So now test train split is running and it has run successfully. Now we'll be looking at the test shape and the train shape. So according to the 33% case scenario, we have 1157 entries as training and 571 entries as testing, and 6 means there are 6 features, because obviously there are all total 7 features, and out of it what we are remaining with the 6 features for input and 1 will be used as output. Okay, now feature engineering. Here comes the feature engineering part. Feature engineering is very important. So how feature engineering is important? Because we have to see what our data exactly looks like. We have to visualize it. We have to remove if any unnecessary feature is this. So this increases our predictive power and our model will obviously performs well. So let's run and check the data type and the training variable. So here you can see that everything is categorical. Okay, so the only problem in machine learning model comes with that we can't deal with categorical features. We can't deal with strings, vectors. So what we do, we convert these strings and objects into numeric data types. So how we'll be doing it with the help of what called encoders. So if we look that each and every is a strings and object basically. So we have to convert it into numeric. Let's say let me show you with the example. Let's say we have certain classes like good, very good, accurate and inaccurate. Let's say we represent inaccurate as 1, accurate as 0, good as 2 and very good as 3. So now they have converted into integer. So now the model can easily learn because it works well with the integer data type and not with the categorical or object features. Objects doesn't work with our models, so we'll be just encoding it in the forms of numbers. It's a very simple technique, doesn't bother you much, I hope. So we'll be importing categorical encoders. Okay, and we'll be running ordinal encoder, and after running that we'll be running fit transform.